Bright Duty. Every student matters.
Hello students, I am Shavika and we are doing the chapter Periodic Classification of Elements. Now as we started in the previous class, all that is matter around us is made up of elements, compounds or mixtures. Elements are made up of atoms of similar type, whereas compounds are formed when two or more atoms of different elements or same elements combine together. Whereas mixture is just a physical bringing together of different elements or compounds. So now that we know this, we will try to understand what were the elements that existed around us and how did we discover them and how did we go about arranging them. So back around the year 1800, there were only 30 elements known to man. So we did not know about the existence of other elements, mostly because either they were inert or we did not come across them. So 30 elements only were known up until that point. But later on, with a lot of advancement in technology and science, we are now familiar with 118 elements present in the earth. So amongst these 118 elements that we know of today, 94 are naturally occurring in nature. And because there are so many elements, there came a need to organize them. There was a need to classify them into in a pattern that we could study them better. Why did we need to organize them? The first reason was for studying them. We needed a systematic fashion in which we could study elements. We can't go on studying one element from the other. And so we needed a structure to understand all the elements properly. Another reason was a lot of elements show similar properties, similar chemical properties. To understand why is it that they show similar chemical and physical properties, we needed to group them together. So for grouping similar elements together and for understanding and studying them, there was a need for classification. Now back in the time, it wasn't always as easy to classify because technology was not that developed. So we did not know about the atomic number, that is the number of protons or neutrons. That kind of specific information was not available to us. So atomic number, which is the number of protons, was not discovered up until this point. So the first attempt was made by Dominius, Johann Wolf Dominius, in 1817. He was a pharmacy student in Germany who later on became a professor at University of Jena. What he did was he tried to put elements with similar properties into groups. So he tried to make groups of 3 and he called each group a triad. And he wanted to put together only those elements together which had similar properties. He was able to come up with 3 triads: lithium, sodium, potassium, calcium, strontium, barium, calcium, bromine and iodine. So these were his 3 triads. When he arranged them like this, he also observed that when 3 elements in the triad were written in the order of increasing atomic masses, the atomic mass of the middle element was roughly the average of the atomic mass of the other 2 elements. So here, lithium and potassium, if we take the average of their atomic mass, according to Dominius, we would get somewhere around the atomic mass of sodium. So let's try and do that. You see that the lithium's atomic mass is 6.9 and potassium's is 39. So when we add 39 to 6.9, we get 46. When we divide this by 2 for average, we get 23, which is exactly the atomic mass of sodium. So this was a pattern in the arrangement made by Dominius, that if you arrange them in the order of increasing atomic mass, then the first and the last, if you take the average of the first and the last element in that triad, you would get the atomic mass of the middle element. So there's also this question which you can you see to understand if this is a Dominius triad or not. So let's take the first one first. It has nitrogen, phosphorus and arsenic. So when we add 14 with 74.9, we get 88.9. Talking about group A here, 88.9 we'll get by adding 14 and 74.9. When we divide it by 2, we get 44.45. So what does this show? It is very far from the atomic mass of phosphorus, 31 and 44. It's really far, and that is why it is not a Dominius triad. But when you see it for other groups like group B, as it's also shown here, So when you add 40.1 with 137.3, you get 177.4, and when you divide it by 2 for average, you get 88.2, which is quite close to the atomic mass of strontium. So it is actually a Dominius Triad, and you also saw this before. So it doesn't have to be exactly the same atomic mass, but it can be somewhere close also. Again, when we do it for group C, as also shown here, you can see that when we add 35.5 with 126.9, we get 162.4, and when we divide it by 2, we get 81.2. Again, very, very close to the atomic mass of bromine, and that is why it is also one of the Dominius Triad. So if you get a question like this, you just have to find the average of the first and the last element, the atomic masses of them, and then you will, if the average of the first and the last atomic mass is close or almost equal to the middle element's atomic mass, then it is a Dominius Triad.